First of all, I'm going to discuss about the question paper which was set in the examination and their respective answers. And then I'm going to discuss about our new topic. And hope your examinations went pretty well. There is only one mistake. Mistake in the sense that mistake is on my part. It's nothing serious. It was about when I said the fill in the blanks, probably that mark wasn't counted. The fill in the blanks question auto correction was not made properly. So I shall go through your chart, and if I find that you have responded correctly, but the thing hasn't been calculated, then I shall put the marks over there and I will send it to Google Classroom so that all of you can see your marks. And your marks are pretty good. Okay, so I'm pretty much impressed that you have performed well in the examination. So you are in the safe side. And 18 people have joined, but only 8 people have written their roll numbers. So please write your roll numbers, and I'm beginning my today's session. My today's session is about the discussion on the questions of the problems which I set in the examination. In the morning, the question was set for question section B, and when your sessions came, then before that I actually changed a little bit of the question. Okay, to avoid the malpractice. To be on, I wanted to be on safe side. Now, anyways, so here in this particular question paper, I have shown you both the questions which section A answered and the question which you answered. So you may become confused that question was not there, but sir is discussing. That's why I'm saying. Now, anyways, the first question was this. That figure was there, and the rectangular box is the sample space, and in the sample space there are 2 sets. Okay, and in the set there is an intersection point. You can see very well this intersection point is represents the probability that both the events are happening simultaneously. Now, my question was, what was the probability that event A will happen given that event B, or what is the probability that event B has happened given that event A? Now, you see in this rectangular box, there are some other probabilities like 0.12 and just a minute, 0.12 and 0.27. These probabilities do not belong to the sets capital A and capital B. These belong to some other sets. Maybe there are 2 more sets like C and D. So these probabilities belong to that event. But we are not interested about those events. So we just drew the figure corresponding to the event A and event B. Now, when we talk about probability of event A given that B has happened, by definition it is probability of the simultaneous event, the happening of the event simultaneously. The probability is taken on the numerator divided by the probability B, which comes to the denominator. And if you look at this picture, you see that probability of this simultaneous occurrence is 0.16, so it is written over here, and probability of B, total probability of this event, which has been counted as 0.16 plus 0.22, and therefore the probability comes as 0.4211. Similarly, if I reverse the question, the nature of the question, then probability of B given A becomes probability of the simultaneous occurrence of A and B divided by probability of the event A. Now, this simultaneous occurrence has again probability 0.16, and the probability of A will be this total, total of these probabilities, 0.21, 0.16, 0.02, and therefore this value is 0.4103. So that is how it is calculated. Now the next question was, two fields were shown to you. One field contains an agricultural field which contains 9 plots, and another field contained 12 plots. Now you are supposed to find that if you select a plot at random, and if you select say 2 plots, one from this figure and another from this figure, at random and independent of one another, the selections are made independent. What is the probability that both selected plots are corner plots? What is the probability that neither plot is a corner plot? What is the probability that at least one of the selected plots is a corner plot? That was the problem. Okay, let me save your chat because it is also very important besides taking class. Anyways, now let me discuss question number 1 first of all. Look at this plot. What is the probability that both selected plots are corner plots? Okay, so if I denote the event capital X as selection of the plot from figure 1 and capital Y is the selection of plot from figure 2, then question number 1 asks for the simultaneous occurrence of the event capital X and capital Y. And capital X and capital Y not only represents the selection of the plots, but they represent selection of the corner plots. Now probability of X intersection Y will be probability of X into probability of Y is because your selections of the plots from these two fields, agricultural fields, are independent of one another, and therefore this product sign. Now you apply the classical definition of probability. Here the total outcome is 9. 9 plots are there, out of which you are going to select one corner plot. So there are 4 possibilities: this, 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 and this. So I have written here 4 by 9. And for similarly, for this selection, 4 corner plots are there: this, 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 and that. Okay, so 4 out of 12. So I have written here, and I multiplied, and we got 4 by 27. So question number 1 is pretty straightforward. It's an application of classical definition of probability. Let us go to the question number 2, and I know very well that you have correctly measured it, but regarding question number 2, I have to tell you something. So it will be much better if you have pen and paper with you, so that if I say something, if I'm going to give you some input about question number 2, and you just quickly note it down. Also, I'm going to send this question, this particular solution to the Google Classroom. I'm going to upload it this evening, but still, you just be ready with your paper and pen. Now, since we are in lockdown, so you have already got the pattern of the question paper that can be asked through online examination. But if there is written examination, okay, and you have to solve the problems manually, then I always suggest to you to define events and to apply the axiomatic approach. Okay, I don't know what approach you applied to solve this particular problem, but always try to apply the axiomatic approach for better understanding of the problem. So we are going to solve question number 2. We have already defined the events, capital X and capital Y. Question number 2 asks for neither plot to be corner plot. So that means you are supposed to find probability of X bar intersection Y bar. Complementary event to X intersection complementary event to Y. And by De Morgan's law, X bar intersection Y bar is nothing but same as X union Y bar by De Morgan's law of set theory. And X union Y bar is the complementary event of X union Y. So probability of A complement is 1 minus P, 1 minus A, P of A. So probability of X union Y bar will be 1 minus probability of X union Y. And here you can apply the formula for probability of A union B. So I have written probability of X plus probability of Y minus probability of X intersection Y. And again, you know that the selections are independent of one another. The probability of X intersection Y has been written as Px into Py. And after a little bit of simplification, we get 1 minus Px multiplied by 1 minus Py. And 1 minus Px is Px bar and 1 minus Py is Py bar. Px is what? Px is 4 by 9 and Py is 4 by 12. So Px bar will be 1 minus 4 by 9. Py bar will be 1 minus 4 by 12. And the result comes out to be 10 by 27. Now the result has come. Okay, my job is done. But what I wanted to say to you is that, you see, during this example, I have solved one particular theorem, interestingly. What is the theorem? The theorem says, carefully look into this. When we say that capital X and capital Y, these two events are independent of one another, probability of X intersection Y becomes Px into Py. Their complementary events are also independent. Probability of X bar intersection Y bar becomes probability of X bar into probability of Y bar. This is a very, very, very important theorem. Okay, if two events are independent of one another, their respective complementary events are also independent of one another. Very important theorem we have proved while solving the problem. So I have noted down this theorem here so that all of you can see. We see above that if two events are independent, then their respective complementary events are also independent. Okay, that's why I told you to always to apply axiomatic approach. Maybe because something interesting may come out of the problem itself. What was the last problem? What is the probability that at least one of the selected plots is a corner plot? So there are, you see, three possibilities are there. What are these possibilities? At least one corner plot is, at least one plot is corner plot. So three possibilities are there. In the first selection, you can see that a corner plot appears, X. But in the second selection, the plot is not a corner plot. So here is one possibility, X intersection Y bar, or which is represented by union. First selection, no corner plot. Second selection, corner plot. So that is another possibility. Or represented by union, both selections represent corner plots. So we get, since all of these events, bracketed events, are mutually exclusive, so we write probability of this plus this plus this. And now X and Y are independent, so probability of X into probability of Y. Also, I have not proved the result here. I have kept it for you. Probability of X intersection Y bar will also be independent. So you note in your copy that if capital X and capital Y are independent events, prove that X and Y bar are also independent. X bar and Y is also independent. These are another two theorems. I have proved this for you, but you are supposed to prove by Venn diagram, using Venn diagram or set theoretic logic, that this also holds good for two independent events, capital X and capital Y. I have used their results only here. So by that result, this can be written as Px into Py bar. This is Px bar into Py, and therefore put all the values and you will get 17 by 27. Specifically for these theorems, which have not been discussed in the classroom, I set this particular problem in the examination. But I knew that you would be able to solve the problem, if not by axiomatic approach, but by some other way. Okay, so I was little bothered. But you have to keep this approach in mind. Third problem was this. A diagram was shown. This diagram represents the probability mass functions value for 6 discrete values of the random variable capital X, 1, 2, 3, 4, 5, and 6. And you are supposed to find the probability that this discrete random variable lies between 3 and 6. Now, here 3, the value 3 is included and 6 is excluded. So the possible values for x will be probability of x equal to 3 plus probability of x equals to 4 plus probability of x equals to 5. 6 will not be included, and therefore the counts are given over there, the probability counts. For x equal to 3 it is 0.3, for 4 it is 0.2, for 5 it is 0.1. So you add these figures, 3 figures, and you will get 0.6. So that's how this particular problem is done. I gave you a problem where it was written that let capital X be the random variable whose sample space contains the integers of the entire real line. Although the domain is entire real line, but you have to remember that capital X is not continuous. Capital X will take the discrete real numbers from the domain. Okay, and if capital F of small x is the corresponding distribution function, then the value of the distribution function at extreme ends, at minus infinity and at plus infinity. I have already mentioned this result in one of my earlier notes. The values are respectively 0 and 1. But during the examination, I changed the question a little bit. I set only one value. I cannot remember right now, probably this one. And I asked, this can have values 1 or minus 1, 2 or minus 2, like this. None of this. So answer is none of this, because these values have this particular expressions has unique values. It cannot be like this or that. So that our reply should be none of this. And the answers are 0 and 1. This is a theorem actually, but the proof of the theorem is not there in our syllabus. It's a bit mathematical and you will not find it interesting. But remember the result. Probably in some problems you may have to apply this particular result for solving problems. Results are very important. Now, this problem was not there in your, this problem is the problem which is in front of you right now. Question number 5 was there in your question paper, but in a different way. I asked if capital X is a Poisson-variate with parameter m equals to 2. That's what is the mean of the random variable. Now let me discuss this. That is in front of you. This question was set for section B, students of ECE. What is written? If a capital X is a Poisson-variate with parameter lambda equals to 144, what will be the value of the standard deviation of X? Now, if you can remember, I told you that capital X, if Poisson-variate, then its probability density, probability mass function will be of this form. And the parameter of the Poisson-variate is lambda, and that parameter is for that parameter of Poisson-variate is its mean as well as its variance. So Poisson-variate is a kind of variable whose mean and variance are same. Here, and that is equal to, that those values are equal to the parameter itself. So parameter is mentioned here. It is 144. So here the variance of the Poisson-variate will be 144. And standard deviation is root over variance, positive square root of the variance, because standard deviation measures the scatteredness of the points of the distribution about the average. So that will be root over Vx, and therefore the answer will be 12. For your case, I set the question like this: if lambda equals to 2, what will be the mean of X? So also for Poisson-variate, the mean is equal to the parameter itself. So here, if in the question, if in this question, if I ask what is the mean, if lambda is given to be the mean 144, then here the answer will be 144. In your case, the answer was 2, because the values, if I can remember, the value was 2. Then I gave this problem to you. Now you just quickly note question number 6 in your copy, because this question number 6 is also related to our today's topic, today's new topic, which I'm going to discuss with you. So we just quickly note it down. But the calculation is very, very easy. Okay, it's a straightforward calculation, and you all could solve it very easily, just by applying the properties of expectation and the variance. Expectation of capital X is given to be mu. I am supposed to find expectation of the random variable y. Expectation of random variable y is what? Expectation of this expression. Now, under this expectation, 1 by sigma is the constant. Now, constant comes out of the expectation sign. So you can take 1 by sigma outside. And inside bracket, you will get expectation of x minus mu. Expectation of x minus mu will be, by the property of expectation of x minus expectation of mu. Expectation of x is given to be mu. And expectation of mu is the average. So expectation of average is a constant quantity. So expectation of average is average. So expectation of mu will be mu. So we get mu minus mu. And therefore expectation of y is 0. Similarly, if I calculate variance of y, so we get variance of this entire expression. And you know, by the result, by the property of variance, the variance of the random variable, when it gets multiplied by the constant comes outside the variance sign with, and it gets squared. So variance of cx becomes c squared variance of x. Here the constant is 1 by sigma, and it comes out of the variance sign and it gets squared. And we get 1 by sigma square variance of x minus mu. X and mu are independent of one another. So variance of x minus mu will be variance of x plus variance of mu. Try to recall, variance of x minus y is variance of x plus variance of y minus 2 covariance xy. But since x and y are independent, covariance term vanishes. So here x and mu are independent. One is constant, another is random variable. So variance of x minus mu will be variance of x plus variance of mu, not variance of x minus variance of mu. That is wrong. And variance of mu means variance of some constant quantity. Constant quantities doesn't vary. There is no variation for constant quantity. So variance of mu will be 0. And variance of x, what is the value of that? Since standard deviation of x is given to be sigma, and variance squared is standard deviation, so standard deviation x, if standard deviation of x is sigma, variance of x will be sigma square. So ultimately for variance of y, we get sigma square by sigma square. And therefore, ultimate answer comes out to be 1. So variance of y is 1. What is the next problem? Let me see. Question number 7 says, suppose that the number of customers who enter a bank in an hour is Poisson-variate, and suppose probability of x equal to 0 is equal to 0.1, then the average of the random variable x is this, variance of the random variable is this. Probably this question was not there in the question for section A. It was probably there for section B. Yet, let me discuss the problem. Okay. The equation is given to be this. Probability of x equal to 0 is equal to 0.1. Now, capital X represents a random variable which denotes the number of customers entering into the bank. And since it is a Poisson-variate, probability of x equal to 0 is probability of the value of the PMF of the Poisson-variate at x equal to 0. The PMF is defined by this for Poisson variable. And here we put x equal to 0. And ultimately we get e to the power minus lambda on the left hand side. On the right hand side we get 0.1 as it is given. And we take the natural logarithm on both sides. We get minus lambda multiplied by ln of e and ln of 0.1. And ln of 0.1 is minus 2.302. Both sides having minus sign will cancel each other and we'll get lambda is 2.302. Parameter has come out as 2.302, and we know for Poisson-variate, the parameter is the mean, the parameter is the variance. So 2.3 is both mean and variance for the respective Poisson variable, representing the number of customers entering the bank. So answer is 2.3. This question was there probably in section B. I cannot recall right now. The question was, the phone lines to an airline reservation system are occupied 50% of the time. Assume that the events that the lines are occupied on successive calls are independent. Assume that 10 calls are placed to the airline. What is the expected number of calls in which the lines are all occupied? Probability of success. Success is all the telephone lines will be occupied. That is the success. Its probability is given to be 50%. 50 by 100, that means 0.5. And the 10 calls are there. That is the number, total number of experiment. Okay, what is the expected number of calls? Expected number means average number of calls that the lines will be occupied, will remain occupied. So definitely number of calls means n is known, probability of success means p is known. So it's a problem of binomial probability, binomial distribution. And for binomial distribution, the average number of calls is calculated by number of experiments multiplied by the probability of success. So 10 gets multiplied by 50%, and we get 5 as the answer. 5 calls. 5 calls will justify that your numbers, your telephone lines will be occupied throughout. Your airline system will be occupied throughout. Okay. On an average, 5 calls will be there. This question was not there for section B. This question was there for section A. What is the question? Suppose that the number of telephone calls coming into a telephone exchange between 10 a.m. and 11 a.m. Say capital X is the random variable with Poisson variable with parameter 2. Similarly, the number of calls arriving between 11 a.m. and 12 noon, say Y has Poisson distribution with parameter 6. If capital X and capital Y are independent, what is the probability that more than one calls come in between 10 a.m. and 12 noon? Now there are 2 time limits. One is the morning time limit, and in morning there are 2 time limits. One is from 10 a.m. to 11 a.m. and another is from 11 a.m. to 12 noon. Now the coming of the telephone calls is always Poisson variate. It's because you cannot, now you all are sitting and you are attending my online class. You never know who is going to call you now. What is the probability that I'm going to call one of you right now? Do not know. I may call you, or somebody else may call you. Okay, so the number of calls, you do not know the nature of the incoming calls. Okay, there are no regularity in between them. Okay, they are irregular. They can happen any time. You do not know how many times, how much longer you have to wait to get one particular call. Okay, if you are chatting with someone, that is different issue. But if you are not doing anything, you're doing your household works, do not know when your phone is going to get ringed. So a particular friend of yours is going to call you. So capital X, the number of phone calls is always a Poisson value. The probability of success is very poor. Here also, the Poisson variate, this number of calls between these time limits is a Poisson variate with parameter 2. And here is another random variable which also represents the number of calls, but between the time limits 11 a.m. and 12 noon, its parameter is 6. What is the probability that more than one call will be received between 10 a.m. and 12 noon? That means the 2 time limits have been merged together, 10 a.m. to 12 noon. 2 time limits are being merged, means 2 random variables are getting added, x plus y. The question is asking for something for x plus y. What will be happen to the parameters? In this case, there is a result which says that if the nature of the random variables are independent, then the parameters will also get added. So the answer to the given problem will be probability of capital X plus Y will take the value small x plus y with parameter 8, 6 plus 2, whose formula is given as the formula of Poisson variate, which is e to the power minus 8 into 8 to the power x by x factorial. X will take values from 0, 1, 2, 3. So the random variable x plus y will take the total number of calls, okay, and during the entire range from 10 a.m. to 12 noon, and you are supposed to find what will be the probability that more than one calls will be received by the random variable capital X plus capital Y. And it is represented by this expression, probability of X plus Y greater than 1, which is 1 minus probability of X plus Y less than or equal to 1. Discrete case, so two possibilities, 0 and 1. And you put the values. Rest is all right. Main important portion is this one, to add the parameters. Okay, if the variables are independent. Okay. And the last problem was this. I have not solved the problem, but I'm just showing you the equation which needs to be solved. Let capital X be a binomial random variable. And you know, for binomial random variable, what will be the form of the PMF? Parameters value is given to be n equals to 6, and this equation is given. Now you try to apply this equation. And you apply the formula of the binomial probability law, and you will get 9 into 6c4 p to the power 4 1 minus p whole thing to the power 6 minus 4. On the left hand side, 6c2 p square 1 minus p whole thing to the power 6 minus 2 on the right hand side. Solve it and p will come out. The probability of success will come out. Okay, so I have not solved. I have kept it for you so that you do the calculations by yourself. Probably you have already done in the examination. So this was all about, I wanted to discuss about the answers to the question, and I shall check your responses. Your responses are good, but the one fill in the blanks question was there. If that mark hasn't been added somehow, then I will add the mark and I'll send your marks to the Google Classroom so that all of you can see it. Now I'm going to stop this sharing. I'm going to share something else right now. Okay, hope you have understood, and you are going to get this solutions sheet by today evening. Okay, so where is this? Yeah, this one. So my today's topic, can you see this new screen?
Yes, sir.
Yeah,
Yes, sir.
yeah, the topic is continuous probability distribution, discussion of continuous probability distribution carried forward to normal variable. And remember, students, one more thing, since the countdown has already begun, the time limit is set. Now, during the discussion, if the session gets cancelled out, you again rejoin to the classroom until and unless I ask you to exit. You rejoin because I have to discuss something today regarding normal variable. Now, normal variable, this particular chapter is very, 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 very important in the sense that all my subsequent topics of the syllabus is based upon this. Everything else is based upon this normal variable. So if you do not understand it properly, then you will not be able to solve the problems, subsequent problems. You will not be able to deal with hypothesis testing. You will not be able to deal with estimation of parameter. You will not be able to deal with non-parametric tests. You will not be able to understand Chebyshev's theorem, which has been left out in section 1. You will not be able to understand central limit theorem. You will not be able to understand anything at all. Anything at all if you do not understand what normal variable is, and it will take some time. Okay, so you just I shall go slowly and you just be attentive. Let me define the normal variable first of all. The normal variable is defined in this way. Let capital X be a continuous random variable whose probability density function fx is defined as this. This is my expression for the normal variable. This is the expression for the normal, for the PDF of the normal variable, probability density function of the normal variable. What is this expression? Let me read it for you. 1 by sigma root over 2 pi integration minus infinity to plus infinity. You just note it down in your copy. E to the power minus half x minus mu by sigma whole square dx. X lies between minus infinity to plus infinity. Very complicated expression. Okay, but this expression you will be you'll become gradually comfortable with this expression, because you are going to stick to that, okay, for the rest of the sessions, for the rest of the semester. So this is the probability density function, and if the probability density function is of this form, capital X is said to follow the normal variate or normal variable, okay. And this normal variable has two parameters, just like binomial has two parameters, Poisson has two parameters, but binomial and Poisson, they are discrete cases. Normal variable is a continuous case because its range is from minus infinity to plus infinity. And here also there are two parameters are there for normal variable. One is mu, which is called mean, and another is called sigma, which is called standard deviation. So if mu and sigma are known, you know the nature of the normal variable. So I'm now going to show you what happens when we get different mu values and different sigma values, and what is the shape of the normal variable. So here is a diagram, set of diagrams. See, carefully look into this set of diagrams. Three diagrams have been shown. This is spiked, okay. This is moderate, and that is a little bit smooth, or you can say a little bit flat, okay. So why is this happening here? In each of these diagrams, this middle value 2 is fixed. This value 2 is fixed. Mu value 2 is fixed. Here also mu is 2. Here also mu is 2. But what is changing? Standard deviation is changing. For standard deviation measures the variation of the points throughout the distribution about the mean. So if the variation measured is 0.5, the curve will be like this. If the variation measured is 0.2, the curve will be like this, a little bit scattered. If the variation measured is 4, the curve will be more scattered, okay. But it will remain symmetric about 2. Why is it so? Because normal variable is a very interesting property. It says that if capital X is the normal variable, its mean, median, and mode, these three measures of central tendency, are going to coincide. So here mu equals to 2 means its median is also 2, its mode is also 2. So since its median is 2, that means the median is dividing the curve, the area, the entire area into two equal halves. So if I draw a straight line over here, vertical line, so left hand side will cover 50% of area, right hand side will cover 50% of the area, and it is true for all the three curves. And mu equals to 2 is mode, is because the highest frequency appears corresponding to mu equals to 2. So 2 is mode. But the spike or the flatness is occurring not because of this mean value, but because of the variation, the measure of the standard deviation. And if you keep on increasing the standard deviation, then it will be flatter and flatter and flatter and flatter and flatter. But its natural characteristics will remain same. So normal distribution is a curve. Its curve is also known as probability curve, and it is symmetric about mean, median, or mode. Time is almost running out, so I'm actually pausing here. It will get cancelled. You again rejoin, and I'll continue.